Hi everyone, and welcome to the fourth and final video going through some past exam questions on ionisation energies. In this first question, it's showing us some elements from period 2, and it wants us to explain the trend in the first ionisation energy. Okay, this is going across a period, so we want to talk about the same three factors that we've talked about in all these questions. Okay, hopefully if you've watched the previous videos in this topic, you know what you're going to say by now. These questions just repeat themselves. It's the same answer every time. It's either going across a period or it's going down a group. So across a period, we need to talk about nuclear charge, atomic radius, and shielding. The same three factors. So as you go across a period, the nuclear charge increases. We get one extra proton. The atomic radius decreases. Okay, those electrons get attracted a little bit more by that extra proton, so therefore the radius goes down a bit. And the shielding stays the same because you're adding electrons to the same shell. So overall, the nuclear attraction, which is how much the electrons are attracted to the nucleus, increases. So it requires more energy to remove an electron. Requires more energy to remove an electron. Okay, so I feel like we've seen that question quite a bit. Here we've got to do the definition for ionisation energy. It's worth 3 marks. It's definitely worth learning this definition. Okay, it's a nice easy thing. You learn it, you don't have to use your brain. So it's the energy required to remove an electron. That's going to get us 1 mark. And we need to do it per mole. So it's remove an electron from each atom in 1 mole. That's going to get us the 2nd mark. And then it has to be gaseous atoms. It's going to get us the 3rd mark. And you really want to learn that. Okay, final questions on this topic that we're going to look at. Again, we've been given some data here. We've got 3 elements. We've got their first ionisation energies and we've got their atomic radius. Okay, so explain why there's an increase in ionisation energy between fluorine and neon. Okay, so this is going across a period again. So this is actually, it's a 3-mark question. This is literally the same answer as this. Okay, as we're going across a period from fluorine to neon. So I'm literally going to write that answer again. As you go across a period, the nuclear charge increases. Neon's got 1 extra proton than fluorine. The atomic radius decreases. Look, we can see that. The radius has gone down a little bit. And the shielding is going to stay the same. So overall, the nuclear attraction is going to increase. And it's going to take more energy to remove the electron. So that's why neon's first ionisation energy is higher than fluorine. Okay, I'm not going to write it out again. I really can't be bothered. But it is the same question. So can you see it's worded completely differently? But it's the same 3-mark question. You're still talking about going across a period. And if you're looking here, you're going, well, these elements are in the same period. So it's the same question. So I'm not going to write an answer to that because we've just done it. Explain why there is a decrease in ionisation energy between neon and sodium. Okay, so this is a little bit different. So here we're not going across a period because neon is at the end of period 2 and sodium is at the start of period 3. Okay, so that's the main difference, is that we've got to the end of an electron shell and we've moved into the next electron shell. Okay, so that's the first thing we want to say. The outer electron in sodium is in a shell further from the nucleus than the outer electron in neon. So this means that there is more shielding. And the atomic radius is higher. Okay, they're probably not going to give us a mark for that because they've told us it in the table, but we might as well write it anyway. This means there is more shielding and the atomic radius is larger. And then we still want to talk about our same three factors, right? So we've done shielding, we've done radius, we want to talk about nuclear charge, but we need to be a little bit careful here because sodium does have a higher nuclear charge. It's got one extra proton, but it still has a lower first ionization energy because of the increase in the radius and the increase in the shielding. Okay, so we can say, although sodium has a higher nuclear charge, overall its nuclear attraction is weaker and it requires less energy to remove the electron. Let's say remove the outer electron. Okay, so I hope we're getting fairly confident with these ionization energy questions and just showing you, look, that no matter how they word it, the same questions keep coming up. So if you've practiced these, you can be pretty confident when these questions come up in the exam.